On air, online and squeezed into your smartphone these days, 2NURFM 103.7. It is that time of the fortnight where we have a look at some of the things happening in the world of science. We do that with our Professor of Science from the University of Newcastle, John O'Connor, who has a bit of a cosmic problem for us today, John, and we need to protect our big supercomputers, our self-driving cars, so quite a big chunk of technology, and an ageing problem will help us get there. Good morning.
G'day, Mark. Yes, it's a problem that hasn't gone away. It actually relates to cosmic rays, which very energetic rays produced way out somewhere in the universe somewhere. They bombard our atmosphere, and we're continually being irradiated with energetic particles. People think that we're in a radiation-free zone. Not the case. Here, we're slightly protected by the atmosphere, but we're always under this constant shower, and it's been historically a problem because back in 1984, when IBM started producing their U-Butte desktop computers, personal computers, they found that the ones in Denver were making mistakes 10 times as often, having errors 10 times as often as those at New York. They'd ship these back to New York, they were fine. And it's because Denver's at high altitude, more radiation. You don't have that blanket protecting you.
So it really wasn't a case of a bad workman blaming their tools. It was the atmospheric conditions high up.
And the same thing, actually, it happened to a plane, a Qantas plane, back in 2008, a flight from Singapore to Australia, suddenly pitched forward and started diving. The pilot took over and everything was fine, no one died, but they worked out that was because, or the most likely reason, was a cosmic ray came in, switched a bit in the computer somewhere, because as these semiconductor devices get smaller, it takes less and less charge to flip them. And so in the case of the IBM computers and this Qantas plane, it just needed something to flip somewhere, and you've changed the program or changed the memory.
Now that does pose the great challenge, doesn't it, John? Because as technology improves and it gets better, smarter, it invariably gets smaller, and that is where we have these issues.
It does, and on a light-hearted fashion, there was a story 2013 about someone playing Nintendo, and suddenly Mario jumped up and was teleported through the air. People tried to work out what was the secret code for that. No one ever did. It was just one of these glitches. And in 2009, Toyota had to recall all of its vehicles because they found they were accelerating and people couldn't operate the brakes.
Yeah, it's a huge problem.
It would worry them. And of course, that could well become the case with future cars. So it's not as if this isn't known. It is known, and they've developed correction codes for single-bit changes and sometimes multi-bit changes. But these take time, and as things get smaller, it becomes more important. And as computers cover more real estate, the probability of happening goes up. So, some of these supercomputers or these farms where they have these servers, they're the size of football fields or bigger. So this is more likely to happen. And so what they're doing, what the challenge is how do you create algorithms or mechanisms to detect these errors and fix them, because if you do it the right way, you can actually flip the bit back once you found which one is wrong. But if 2, 3, 4 or 5 go, then it gets challenging.
Good luck to you.
And so these big computers that we're talking about are an issue today. In the future, there are going to be quantum computers, these things which operate much faster than our present computers, and it's shown that they are too susceptible to it. And you mentioned the self-drive cars. So what they've been doing to try and model this is they've got large accelerators, and they've built up systems whereby they can bombard chips and then use algorithms to see if it detected these changes. And so this is going to be an ongoing overhead for computers, because while they're doing a calculation, they're also going to have to do something like check. In fact, some of the big computers spend 12% of their time not calculating, but checking to make sure nothing went wrong. Or for the really big simulations, what they do is every hour they dump the entire program somewhere, hoping that up to that point everything was running fine, and then they keep going. And if they at a later time find something's gone wrong because of a cosmic ray event, they can go back and find which was the last good one. So they don't have to go right back to the start, which sometimes can be days or weeks earlier. They can actually go back to the last good one and then take up from there.
Who knows, John? Maybe all of these times our data gets corrupted, we think it's hackers off in some far-flung land. Maybe it's just the cosmic rays they're hitting it.
Well, I mean, all it's got to do is dive into the local computer, flip a bit, and you could end up getting a really big salary next week.
Oh, great. Let's bring that on. We'll just move the decimal point along. That'll be a good place to start.
It's been known that certain jumps like that have occurred. Oh, not necessarily in your salary. Your salary is
really
high.
hasn't. It really hasn't.
But, certainly these events have been detected in the past where a single bit's changed. They've identified. The reason they can identify what it is because usually it's a power of 2, like it's 1024 or 4028. It's a number that is very definitely identified as a binary number. So it can be detected, or actually even more complex things can be detected, but it does mean that whenever we're designing things like self-drive cars, you've got to have built into the whole system not only a program that does all the fantastic things like identifying people and recognising pedestrians and kangaroos and all that sort of stuff and stop signs, but it's also got to recognise that it could at some stage be corrupted by a cosmic ray shower.
Something for us all to think about there and get those decimal points moving in the right direction for a change. All right, a professor of science with that very cosmically centred problem for us, Professor of Science John O'Connor from the University of Newcastle on 2NURFM 103.7.
A broadcast service of the University of Newcastle.